everyone. Welcome to the Mobile Summit, and thank you for being here for Aida's talk. It's going to be really amazing. It's about animating your way into Jetpack Compose. So, a little bit about Aida. Aida is a software engineer and Google developer expert for Android with over 7 years of experience building Android applications for various industries, ranging from cloud gaming services to satellite data communications to fintech. So, on a personal level, she's that friend who has a to do list for the day, plans everything out, and creates itineraries hour by hour for everyone. So, thank you so much, Ira, for presenting today. And yeah, over to you.
Thank you so much, Pujita. Hi, everyone. Welcome to the Mobile Summit. Today, I'll talk about getting started with animations in Jetpack Compose. So my name is Aida Isaeva. I'm a software engineer at Twitter, Google developer expert for Android, and Women Tech Makers ambassador. And in this talk, I will briefly cover why we need animations, what is Jetpack Compose, what solutions it provides for animations, how can we use them, and how can we customize those solutions. Animations are essential in modern mobile app to provide this smooth and delightful user experience. We need animations to grab users' attention, send visual feedback to user, fill in that wait time, and create that responsive, user-friendly interface. And also because they're just fun, although too much animation is not so fun. In practice, animations are common solutions for like masking slow responses from backend when we have this progress bar running, or generally when the app slow and we put a lot of animations in between, and building a great user onboarding experience and teaching users to be more patient with the app. So what do we developers should expect to receive after implementing animations in a mobile app? Higher user conversion, better usability of the app, more patient users, and most importantly, smooth, stable expected results. So benefits of having animations are obvious. So it is hard to imagine mobile apps without them nowadays. Animations have come a long way in Android. However, introducing and maintaining them on Android has been a historically challengeable task. So in traditional Vue UI system, running two different animation APIs simultaneously was not an easy task. For example, combining duration-based API like Object Animator and physics-based API like Spring Animation would be really hard. It would require a lot of boilerplate code just to get started with it. Also, defining animations in separate drawable resource file and calling it in the main code would cause a context switch a lot. Speaking of main code, another biggest pain point was requiring a boilerplate of code just to start the animations. For example, introducing all the listeners, animation listeners, and the following functions that we needed to add just to make sure our animation can start. Also, having a separate set of APIs in each component for the same animations. For example, transition animations from one screen to another. In activities, we would override pending transition function in order to set the animation between one activity to another activity. In fragments, we would use set custom animations function to add that transition between one fragment to another fragment. And if we wanted to have transition between elements in view groups, like recycler view or like linear layouts, relative layouts, we would need to add XML Android attribute animate layout changes. And because of these reasons and the way Vue UI system was set up, animations in traditional Vue-based system were treated as a nice to have feature for a lot of MVPs and still a lot of Android apps nowadays. But Android ecosystem has always been in active development, and last year it introduced Jetpack Compose. Jetpack Compose is Android modern UI toolkit, and it focuses on building UIs declaratively. This distinguishment is important to note because traditional XML-based style was imperative and multiple generations of Android learned and passed on the imperative way of building UI. So what's the main difference between declarative and imperative styles? Imperative style focuses on how, it provides sort of a step-by-step guide how you would like to get your desired result. The declarative style focuses on what, you describe what result you would like to achieve. And because of that, the declarative approach removes quite a lot of boilerplate. Jetpack Compose also provides powerful and extensible APIs that make it easy to implement various animations in the app. Many Compose animation APIs are composable functions, just like rest of the Jetpack Compose UI elements. And these APIs are divided into two groups, high-level APIs and low-level APIs. High-level APIs are easy to use, require minimum actions to start the animations, cover several common patterns, and align with the best practices of material design motion. However, it's important to note some of these APIs are still experimental, means there's a possibility in the future they may get removed. So there are 7 high-level APIs, right? Animated visibility, crossfade, and animated content are containers, right? So we have to think of them as a containers, means inside those containers, we can pass a content, additional composable functions like columns, or like rows and so on inside them. So that's what they hold the content inside. And then we also have modifier extension function, animate content size, animate, and then additional animate as state, update transition, and remember transition functions. All these composable functions are all you need to build animations in Android Jetpack Compose, whether it's to use the default variations or customize them. So let's go over each animation and see how we can use them. So if you want to animate appearance and disappearance of the UI element, animated visibility is the API to use. Under the hood, it creates a custom layout for its content, and the size of this custom layout is defined by the largest width and then the largest height of the child. And all these children will be top start aligned. It also comes, as you see in the source code, it also comes with the default enter transition, which is a combination of the fade in and expand in, and the exit transition, shrink out and fade out. The compose function is a container. This composable function is a container, and by default requires a content composable and the parameter visible that will define visibility of the UI element. It's important to note when this parameter's value, the visible parameter's value changes from true to false, then the content composable will be removed from the tree and disposed. Calling this function to use animated visibility, we would actually introduce animated visibility in our composable function, add the content in, and pass the state of the Boolean type. For example, if we want to reveal an information about the plant cell, right, some sort of plan upon clicking on a button, as we see on the image, we can wrap this plant cell inside the animated visibility, pass to show variable to it, to show it's our state of type of Boolean, and update this to show upon clicking on a button, right? Click listener inside the button composable function. So as you see, with just 2 lines of code, we were able to create this smooth appearance and disappearance of our plant information. Animated visibility is a composable container, as I mentioned again, where the content can have its own animations and transitions. For example, if we want to use the same example of appearing and disappearing the plant cell, we can also decide to put some sort of animations inside that plant cell. For example, changing the background color from one color to another every time when it appears. So then therefore, the plan cell itself will have child animations inside. Also, it's important to note that the enter and exit transitions can be customized as well. In the original source code, we had the combination of fade in plus shrink out, right? So if we want, we can decide to combine or pass our own custom transitions that I will talk later in the customize section. And also it's important to note, if we have this custom enter and exit animations, animated visibility will wait until all the animations completed and only then come to this idle state, like completely finished state for us to know. Next up is crossfade animation. As the name suggests, it animates between two layouts with a crossfade animation. This composable requires content and target state parameters. The interesting parameter here is animation spec. It stores specification of the animation, including the data type that needs to be animated. In this example, it's a float, and the configuration that will be used in the code above will be used. In this example, it's a finite animation spec. And thanks to animation spec, running physics-based and duration-based animations simultaneously comes out of box in Jetpack Compose. Again, I'll cover the animation specs later in a custom animation section. So to use crossfade animation, you call crossfade anywhere inside the composition, add the content in, and pass the state of any type. For example, if we want to replicate sort of a view page behavior and show information about 3 plants by clicking on the next or previous buttons, as we see on the image, we can wrap plants composable function inside the crossfade, pass the number variable, and then increment or decrement the number variable every time when the button is clicked. And just like animated visibility, crossfade is composable container that holds the content where each content can have its own animation. We can also pass an animation spec as well. It is important to note in Jetpack Compose v1.1.1, crossfade is still experimental. Next up is animated content. Animated content is a container that automatically animates its content when target state changes. So animated content is more fluid, flexible, and transformative version of the crossfade. It's far more powerful, I would say. So it requires 2 parameters, the content and target state. The content for different target states is defined in mapping between the target state and the actual content composable function. When target state changes, content for both new and previous target states will be looked up through the content lambda, which is a content. Then they will go through the content transform so that the new target content can be animated in while the initial content animates out. Once the content transform is finished, the outgoing content will be removed from the tree and disposed. By default, the target content has this delayed fade-in animation, and the outgoing content has this delayed scale in and fade out animation. Also, there's another interesting parameter, transition spec, which is expecting content transform that I will cover in a customizing animation section. So to use animated content, again, you would call animated content inside your composable functions, like right now it's inside the column. Add the content that you want to add. We're using plants here, and pass the state of any type. Again, using the previous example from the crossfade, let's replicate this sort of a view page behavior where we can use animated content that gives this fade out and scale in animation. As you see, like it's a kind of a smooth, slow flash happening between exiting and entering animation. And so to cover, animated content, again, is a high-level animation API. It's a composable container, not a function. And because it's a container, the child content inside this container can have their own custom animations as well. And on top of that, you can proceed and pass this transition spec parameter to define your completely customized animations. And again, in v.1.1, animated content is still experimental. Next up is modifier extension function, animate content size. This modifier animates its own size when the child composable at the tail of the chain or child modifier changes the size. And by default, there is no required parameter to this function. So how can we use this animate content size function? What we can do, we can just add it to any modifier, add it to any modifier. Like, for example, let's say we have this toggle list example. Whenever user clicks on one of those rows, the following information is displayed, and we see a lot more. The list gets expanded with the more description, right? What we can do is we can add animate content size to the modifier of our column, right? And that the description part we can wrap with to expand mutable state, right, of type Boolean that will tell us whether we need to expand or whether we need to display this description text or not, you know, and it changes to true and false whenever user clicks on the bottom, as you see inside the clickable modifier function. So it will give us this kind of smooth transition between showing, like kind of expanding the list, toggle list, and then collapsing the toggle list. Animated content size is an extension function, unlike other previous high-level APIs I mentioned, and it cannot contain child content, right? So therefore, it cannot contain the animations. Although we can pass custom animation spec and as well as optional finished listener to know whenever the animation of this content was completed. Next up is animated as state function. So I have the star that represents the name, different name of the functions, because animate, there could be animate float as state, animate color as state, and so on. So, and it's under the umbrella of animate as state function. This one is the simplest animation composable function for animating a single value. Out of the box, Compose provides support for 9 types, like float, color, DP, size, total of 9. And then with animate as state function, there is no need to create an instance of any animation class or handle interruptions as it manages everything under the hood. So let's take a look at the example of animate size as state, state's source code. It has a target value of type state, of type size, right? It also has animation spec and finish listeners parameters of type size as well. So basically, all these animation as state functions are built in a similar fashion where the type is different, and the return, it's going to return as state of this specific type, right? One of these 9 types. Animate the state requires only like one target parameter, and the API starts from the current value to the specified value. So that's why it handles these interruptions out of the box for us. In this example, where the size of the container changes from square to rectangle to vertical to horizontal rectangle, we introduce a variable size state by calling animate as state, animate size as state function, and then pass to it the desired target value based on the count state variable. So we said if it's going to be 1, we want to make a vertical rectangle. If it's 2, it's going to be square. Otherwise, we want to make a horizontal rectangle. And then inside the modifier function size, we called the fields width and height from the size state, and we were able to get the smooth animation of changing the size of this column. So animate as state is a composable function that returns a state, right? It has 9 data types support out of the box. However, if we provide two-way converter, it can support even custom data types. It also provides finish listener to observe the end of the animation. Next API is update transition composable function. It creates and remembers instance of the transition and updates its state. And so transition manages one or more animations as its children and runs them simultaneously between multiple states. The required parameter here is target state. After initializing the transition, we can use one of those animate extension functions on the transition to define child animation in this transition. And just like animate as state, animate function supports different data types out of the box, a total of 10 with additional animate value extension function. So to use update transition API, let's look at example of changing background color and the opacity of the column container whenever the button is clicked. First, you would introduce a variable transition by calling update transition function and passing the target state to it. We're still using the same target state, the target state count from previous example, which was a mutable state of type of integer, right? And then we would create two other variables, background and alpha, and we would call animate color and animate float of transition on them, right? Inside those functions, we have specified the desired values of background and alpha based on the result of the target state. For example, if target state is 1, right, then the background color will be brown with 30% opacity. Otherwise, it will be green color with 100% alpha, right? There is no opacity added to it. Then we would pass these variables into modifiers functions alpha and background, right? So that's how we were able to use update transition animation API. So update transition animation API is a function that returns transition. It can create and manage multiple animations via animate extension function, where we can optionally define a custom transition specs. For more complex transitions involving multiple composable functions, we can use create child transition function and create a child transition, right? So that this create child transition is available on the transition class. And the last high-level composable is remember infinite transition. This function creates and returns the instance of infinite transition. And just like transition, infinite transition can hold one or more animations. However, they start running as soon as they enter composition and won't stop until they are removed from the composition. So infinite transition, unlike update transition, can have only 3 animate functions, or has right now only 3 animate functions: animate color, animate float, and animate value. So now if we look at the source code, one of those animate functions, we can see it requires initial value of type, in our example, color, target value of type color, and animation spec of infinite repeatable spec, right? Again, of type color as well. That repeats animations for infinite amount of iterations. So let's say we want to sort of imitate a squeeze and release animation of our container. We can use remember infinite transition API by introducing a variable transition, then introduce a variable width by calling animate float function and passing this initial target value and target value initial value of 150 and target value of 350 float. And also specify an animation spec. In our example, we're using infinite repeatable animation spec and passing type of animation, which is tween, and the repeat mode, which is a repeat mode reverse, means once it does one animation, it's going to start from here all the way back to this and back so. And then we would call the width variable inside our columns modifier function width. That way we will have this squeeze and release sort of animation. So remember, infinite transition is a function that returns a state, can run multiple child animations infinitely that they'll need to be provided animation spec of that type of animation and the repeat mode. As you noticed, a lot of out-of-box animation APIs come with the default animations in them. However, we can customize them by passing our own arguments into animation spec. For example, high-level APIs like animation visibility, animator state, and so on. Transition spec, right, for animated content API, or even target low-level. It's also important to note that transition spec, because animated content is still experimental, the transition spec is experimental as well too. Or target the low-level APIs and build even completely new animations from the scratch. And so animation spec stores a specification of the animation, like the data type that needs to be animated, the configuration that will be once used, after the data is converted into this animated vector. And Jetpack Compose provides different kinds of animation specs out of box, like spring, tween, keyframe, snap, repeatable, and infinite repeatable. If you notice, in previous example with remember infinite transition, we have already used infinite repeatable in one of our animation specs. We passed to animation spec. So first kind is spring. Spring creates a physics-based animation between start and end values. It can handle interruptions more smoother than the duration-based animations, right? Because it guarantees this continuous velocity when the target value changes amid animations. And it can take two parameters, damping ratio and stiffness. So then damping ratio defines how bouncy the spring should be. And there are 4 levels of bounciness. The default one is damping ratio, no bouncing. For example, this GIF illustrates the different bounce levels will look like with the same start time and the same duration. As you see, if we have a high bounce, our brown rectangle will go out of, it will overshoot to the edges, like ends and or starts. Next one is stiffness. Stiffness defines how fast the spring should move toward the end value. And there are 6 predefined levels. The default one is stiffness medium. Again, in this GIF example, you can see how fast these brown rectangles reach the end when they have the same start time, at the same duration. As you see, if you have high stiffness, it will reach the end far more faster. And if you have very low stiffness, it will reach the end slower and slower. So to show examples of different kind of animation specs, I'll be using the same animate DP as state API with a target value of 0 DP and when the animation is in a kind of idle state, and value of 330 dp when the animation is moving, animation state is moving. So this variable offset animation will be used throughout the examples in the custom animation section. And the only difference will be this animation spec parameter that I'll be passing different kinds. So as you see in this example to the right, when bouncing the plan cell up and down, we're bouncing the plan cell up and down by setting an offset, right, to the columns modifier. And we're getting this bounce effect for free thanks to the spring animation, right? Where we're setting the damping ratio to be high bouncy and stiffness to be low stiff level, right? So it goes like smoothly, bounces up and goes back to the normal position. So this is spring animation spec. Next one is tween. Tween is a duration-based API, right? Duration-based animation. And so it animates the start and end values over specified duration milliseconds with easing curve. We can also specify a delay, to postpone the start of the animation if needed. The interesting parameter here is easing, right? Easing allows this animating value like to speed up and slow down rather than moving in a constant rate. In Android, easing is a function basically that takes the value between 0 and 1 and returns a float. The return value can be outside of the represented boundary, just like the high bouncy. If you notice, the brown rectangle ended up being outside of the gray area. It's outside of the boundary. So easing can also be outside of the boundary to represent sort of a overshoot or undershoot visualization. So Compose provides several built-in easing functions that cover most use cases. For example, we have fast out and slow in easing when we slowly easing in and then leave speed up at the end of the animation to give this fast out example. And so on top of having this custom easing variations available out of the box, we can also specify and define our own easing functions. So cubicbezier.com is a great website to try customize the values and compare your custom easing with the most popular easings that are available. In this example, in the GIF, as you see, I have created a custom easing with the parameters of 0.68f, 136f, 0.55f, and negative 0.2f, right, in the Cubic Bezier. And then I clicked on a Go button, right, to see how newly created easing, which is in pink, right, will behave comparing to regular ease, which is in blue. As you see, that pink square, slows down in the middle, then backs off, and then reaches the end, right? So defining custom values, this way we can define our custom values in Cubic Bezier, right? Cubic Bezier, and add these values inside our Cubic Bezier easing class that is available in Jetpack Compose. So let's take a look at the example with the same values as we used in the previous screen, right? As you see, I've modified the animation spec parameter, passed the tween, set the duration mils to be 500 milliseconds instead of 1000 milliseconds that I used previously, and set the easing to be more custom, Cubic Bezier easing with these values. And as you see, our animation sort of slows down right after the middle, then backs off, and then runs to the end, right? If we have longer duration, then it's definitely the slowing down, backing off will be far more smoother in this animation. Next up is keyframes. So the keyframes animation, animates based on the snapshot value specified at different timestamps in the duration of the animation. So at any given time, the animation value will be moved between two keyframe values. Using again the same example, let's modify the animation spec and pass keyframes with a maximum duration of 1000 milliseconds. We will also add the 10 milliseconds delay. And here we're specifying that we would like to reach the first value of 25 dp at 200 milliseconds, and then reach the second value of 280 dp at 600 milliseconds with fast out linear in easing, right? So we're adding this easing as well. And then the reason we define easing in the second value is to determine this kind of interpolation curve for the second part. So as you see with keyframes, we can customize the speed of our animations at specified stamp, like at specified period, like DPs, like, right? Like, because we're using animate DP state, so we can specify how fast we can reach this 25 dp or how fast we can reach the 280 dp. The next step is animation spec snap. So snap is a special animation. Some people might say it's not an animation, but it's an animation that immediately switches the value, from start to end. We can also specify delay if we want, if we want to delay the start animation. So let's take a look at the example. So as you see in this example, I clicked on a button, move, and there's like 500 millisecond delay happening, and then the container jumps right to the top or jumps right to the bottom. There is not much sort of a smooth animation happening, but it's still, showing a snapshot of the value. Like here's at the bottom, we have reached the bottom, here's the snapshot, or let's go up, here's the snapshot value on top. That's where it should be. So this snap is a really cool animation as well too. The next step is repeatable animation. So repeatable runs again duration-based animation, just like tween and keyframes, and it runs it repeatedly until the specified number of iterations. So you can pass also repeat mode parameter to specify whether the animation should repeat by starting from the beginning, like restart, or from the end, like reverse mode. Using again the same example, we're now modifying, we're passing a repeatable to animation spec with tween animation, specifying the iterations will happen 3 times, and the repeat mode will be reverse. And we can see after the click on a button, our plant cell went down, then up, then down. So making it 3 moves in continuous reverse order, right? So this is what repeatable animation provides us. Next up is infinite repeatable. Infinite repeatable is like repeatable, but it repeats for infinite amount of iterations. So then therefore there is no iteration parameter required. We can also pass like sort of an initial start offset that can be used either to delay the start of the animation or fast forward the animation at any given time. So again, using the same example with animate DPS state, I'm passing infinite repeatable to the animation spec, and I have defined sort of start offset at 600 milliseconds, to fast forward to the end of the animation. And as soon as we enter the composition, as soon as I open the screen, my plant cell right now is moving, bouncing up and down, going up and down. But when it started first, it fast forward to down, like at 600 milliseconds, and from there it slows down. As you can see, whenever it goes to down, it's a little bit of like slow down happening. So next way to customize animations is by passing an argument in the transition spec parameter. So transition spec is responsible for creating this kind of animated transitions between entering and exiting content, basically transforming the content, right? And can combine multiple animation specs in one transition spec. I think the easy way to demonstrate the power of transition spec is by showing an example. Let's say we have 2 variables, slide out negative height and slide out positive height, two variables. In first variable, slide out negative height, the entering content has slide up and fade in with initial content slide up and fades out. So sliding vertically, height is responsible for sliding up, right? And then the initial content will be sliding down. So we combine these two animations in one screen for one screen, right? And then combine other two animations for the next screen. Now in the second variable, slide out positive height, our entering content slides down and fades in with initial content sliding down as well, but fading out. So let's take a look at the example of customizing animated content and by providing the transition spec. As we see inside this transition spec, lambda that we pass into animated content API, target state and initial states are exposed. Thus, it means we can use them to further customize the desired outcome. In this example, whenever user clicks on up button, right, the target number is bigger than the initial number, right, like 0, 1, 2, 3. And then it means the next numbers slide up, and then it goes up. However, previous numbers can also fade out, can also have this fade out animation, while the next number has fade in animation.
Hi, Adam.
Yep.
Sorry to interrupt you, but just a friendly reminder that about 3 minutes are left for our session. So we would also need a few minutes for question and answers. So yeah, just let me know when we can start with question answers. So.
Sounds good. Let me then just wrap up this transition spec part.
Yeah. Sure.
Okay, thank you. All right, so like again, back, I want to like walk through this example specifically. So like whenever user clicks on up button, right? So all our transitions, the transition specs, the previous screens, you know, they're all scrolling up, going up, means whether it's the new number, which is a higher valued, higher target state, or the previous number, they're all sliding up, but the previous number has a fade out animation on top of it, while the new number that is sliding up has a fade in animation. And then when you click on the down button, what happens is whether it's a previous number or the next number that's coming in to the screen, all of them have the slide down animation, right? Like slide down animation. However, again, next one has a fade in animation combined, and then the previous one has this fade out animation combined. So it gives us like more smooth transition between different contents. And so to wrap up, also high level APIs, you know, they have this ability, they provide the ability to customize. There's ability for us to customize our high level APIs if we want to have more, you know, if we want to cover like more frequently used animations in the app, right? But if we want to go even more further, like fine-grained control over the animations, the low-level APIs will give us that flexibility and will give us flexibility. All right, so to go over a little bit faster, we have all our high-level APIs, you know, obviously they're based on the low-level APIs, and low-level APIs, they're structured in a way we have animatable here, then animation state. Animatable depends on the animation state, it extends animation state. And as well, all other APIs, the high-level APIs, they all extend animation class. Animation, by the way, class should only be used to manually control the time of the animation. It is stateless, you know, it does not have a concept of the life cycle. And that's why it is recommended to use any other animations above it, with high level and then the animatable and animation state. And so to recap, Jetpack Compose, you know, provides this easy and flexible animations. They come in two levels, high level and low level. where high levels are useful and practical in many scenarios and can be implemented with like 1-2 liner of code. The low-level APIs give you that further control and customization, although it also means that you have to manage the lifecycle, you have to manage interruptions, and so on. Again, speaking of customization, animation spec will allow you combine physics and duration-based animations to create more natural experience. And on top of it, a lot of animation APIs come with default parameters for animation specifications and require a very minimum number of parameters. And so with Jetpack Compose, now adding animations to your Android app is just fun, easy, and intuitive. And that's it. And this talk would not happen without great resources and official documentation guides and all of these other great resources. Also, special thanks to Rebecca Franks for reviewing this presentation. Thank you. If you guys have questions, you can always find me on social media, tag me, ask me questions there, if we don't have time right now.
Thank you so much, Ada. It was a wonderful session, and all of the attendees enjoyed it fully. We have a few questions. So, first one is that what have you found is the best way to learn about different animation properties? What's your process for going from an idea to getting the animation to look like how you want it to?
Oh, that's a good question. That's a great question. As you noticed with the animation specs, when I was actually setting different animation specs, what I usually do is I use the same behavior that I wanna, that like the same container. In my example, it was the just plant cell. And what I wanted to do is to move from X position, from one Y position to another Y position, and I want to see how this animation will be happening, right? And that's why I use the same setup for all different animations to get familiar, with the outcome, to know how they look like and understand what kind of benefits I will get from using them. For example, I've noticed if I want to have this kind of everything related to like progress, indicators that we have, this progress indicators like loading animators and so on, the spring animation just for me personally feels like more natural because it gives that kind of physics based and also the duration based all combined. It's like looks much more beautiful. I feel like if I want to go more further, I can use also keyframes, but just not necessarily, it's not that required. And also like a lot of times animations are especially useful when we transition from one screen to another screen. And I noticed animated content gives that flexibility. Like it's far more powerful and it's easier to use just because you can simply map out the target state, the animations, and so on. So it's simply try and learn, see how it looks like, how you feel about that. Maybe increase the duration to know exactly, like especially when it comes to the easing, right? Like to know like how the curve works, like what you're seeing, how you're liking it, and so on.
Awesome. Thank you so much, Ava, for explaining that. So very quickly, can you, there's one other question. Can you answer that? That can you cancel animations at runtime? Is there any performance issues related to animations that we should be aware?
To related to the runtime. So that's the good. Let me think about that. We can manage it, again, depends, right? Some of them you will be able to cancel and manage, right? Like for example, if we go to lower into animatable, if you create your own listeners, you should be able to manage. However, animate as state already comes with this solution. So I would definitely recommend to use that one because then it can handle all these interruptions. If we need to pause it, like let's say if the app goes to the background and you come back again, that animation will continue from the moment it stopped rather than starting over. And also that's a good point to remember. Um, Again, we also have, let me think through about this stuff. If we can manually stop the animation, right? If we manually cancel the animation. Let me get back to that part. Think through. There must be a way, because like in a regular view-based animation API, we had listeners where we can, cancel the animations anytime we want. So with the listeners, so there must be some way around in Jetpack Compose as well to cancel animations. And then again, it also depends on what animation APIs we want to target, right? Some of them give that flexibility, some of them do not give that much. For example, remember infinite transition will not give you that flexibility because by default, the design of it is just start the animation as soon as you end the composition and finish the animation as soon as you exit the animation. So I have to look into the more specifics of the different animation APIs for that.
Okay, thank you so much, Aida, for explaining that. We don't have any more questions, so thank you, Aida, once again for wonderful presentation, and thank you everyone for joining Aida's talk. And we have many more such amazing talks planned in the summit. So be sure to join other talks planned out and try to browse them, and see you there. So thank you again, Aida. Bye
Thank you.
bye.
Thank you, everyone. Bye bye. Have a great day.
Bye bye.